If the expression above is rewritten in the form of a plus bi, this expression, if it is written in the form of a plus bi, when a and b are real numbers, then what is the value of a? Note, I is equal to square root of minus 1. So what we want to do now is to find the value of a. There is a math theory such that x minus y bracket multiplied by x plus y is equal to x squared minus y squared. So for example, let's say 3 minus 2i bracket multiplied by 3 plus 2i bracket will be equal to 3 squared minus 2i squared, going by this conjugate theory. Therefore, where x represent the 3, this x represent the 3 here, and the y represent the 2i. Given I is equal to square root of minus 1, therefore, let us find what I squared will be. We would need this to work out our solution later on. So, if I is equal to square root of minus I, therefore, what is I squared? I squared will be minus square root of minus 1 multiplied by square root of minus 1. So, square root of minus 1 times square root of minus 1 is equal to this, can be written in this form. Did you know that square root of minus 1 can also be written in the form minus 1 to raise to the power half? So here we have this written in this form to find what I squared will be. So minus 1 raised to the power half multiplied by minus 1 raised to the power half will be equal to minus 1 raised to the power half plus a half. This is exponential. Here we apply exponential theorem, where when you multiply two numbers having powers, if it's multiplication, we add the powers. So here we have minus 1 raised to the power half multiplied by minus 1 raised to the power half will give us minus 1 raised to the power half plus the powers, that is half plus a half, which will give us 1. Therefore, this will give us minus 1 raised to the power 1, because half plus half will give us 1. And you know, anything raised to the power 1 is just that number. So minus 1 raised to the power 1 is equal to just minus 1. So keep that in mind, which we will use later on to work out the final solution. Remember that what we want to do is to represent this expression in the form of a plus bi. So in between here, we are trying to make use of the conjugate term that we expressed earlier on. So remember that conjugate terms is such that x minus y bracket multiplied by x plus y bracket will give us x squared minus y squared. And we also represented this with the x and the y. So what we have done here is this form, this expression which is here, we say let's multiply it by 3 plus 2i divided by 3 plus 2i. we introduce this because this is a conjugate term of this, of this. So we want to apply the conjugate theory here to help us resolve this problem. And you know, this divided by this is 1. So we introduce this 3 plus 2i divided by 3 plus 2i, which is 1. So we introduce this. So we said this form multiply by 1, trying to use the conjugate of this denominator. So this form now multiplied by this, we introduce this 3 plus 2i, which is the conjugate of this. So we say 3 plus 2i divided by 3 plus 2i multiplied by that expression. So, and we know from earlier on that 3 minus 2i bracket, well, the bracket is missing, but just imagine there's a bracket here. 3 minus 2i multiplied by 3 plus 2i multiplied by its conjugate will give us 3 squared minus 2i squared. So here we have this expression where we introduce this, which is equal to a plus bi. So trying to solve this, we know that 3 minus 2i, multiplied by 3 plus 2i, by conjugate theory will give us 3 squared minus 2i squared. And then we have this multiplied by this, which we have written here, 8 minus I multiplied by 3 plus 2i. So we multiply the 2 here on top together and these 2 together, which gives us this. So here we have 8 minus I multiplied by 3 plus 2i divided by this. So now let's open up this bracket up here. So we know that 8 multiplied by 3 is 24 plus 8 multiplied by 2i will give us 16i. Then we go to I here. Minus I multiplied by 3 will give us minus 3i. Minus I multiplied by plus 2i will give us minus 2i squared. Divided by, we open up this bracket here too. 3 squared will give us 9 minus 2i squared will give us 4i squared. And remember, earlier on, we concluded, or we worked it out, that I squared is equal to minus 1. Yes, I squared is equal to minus 1. So we can substitute for I squared here and here. So let's go. So where we have I squared, we replace it with minus 1. So we go on to here. So we know 24 plus 13i. How did we get the 13i? 16i minus 3i will give us 13i. Then we now have minus 2i squared. But we know that I squared is minus 1. So we replace the I squared by minus 1 here. Then we go to the bottom. 9 minus 4. I squared, we replace I squared by minus 1. So 24 plus 13i minus 2i minus 2 multiplied by minus I squared. So we have here 24 plus 13i, but minus 2i minus 1 will give us plus 2, because a minus multiplied by a minus should give us plus. So here we have minus 2 multiplied by minus 1 should give us plus 2. And then now the bottom part, which is the minus 4 multiplied by minus 1. So minus 4 multiplied by minus 1 should give us plus 4. Minus 4 multiplied by minus 1 will give us plus 4. So now we have 24 plus 13i plus 2 divided by 9 plus 4. So we have 24 plus 2 plus then 13i divided by what? 9 plus 4 will give us 13. Good. So 24 plus 2 will give us 26, then plus 13i. All divided by 13. And as we can see, if you can look closely, this 13 here, 13 can cancel out. Here we have all this expression on this top divided by 13. So we say 13 into 26 will give us 2. 13 into 13 I will give us I. 13 into 26 will give us 2. 13 into 13 I will give us I, because the 13 will cancel out, give us 1, we're left with the I. So now we have 2 plus I is equal to that expression A plus BI. So if we say 2 plus I expression is equal to A plus BI, mere looking at this, we know that this represents this. And because this has an I, this one has an I, so this can represent this. So we say 2 is equal to A. If we say 2 represents A now, that means 2 is equal to A. And this expression I, because this has I, so this will represent this. So if I is equal to BI, therefore B is equal to 1. Therefore, the value of A is 2.